Hello and welcome back to Math with Mrs. Becker. Today in calculus, we are going to look at the derivative as a rate of change. Remember in the past when we talked about rate of change, what we're really looking at is the slope. So if I want to find the average rate of change over an interval, here is the formula. Okay, now check this out. Let's say my function was f of x. If I had an x value that was a, my y value would be whatever you get when you plug a into your function. So it would be f of a. Then if my x value was a b, the y value would be f of b. So if I want to find the average rate of change, check this out, you guys. It's actually the slope. The second y minus the first y on the top. Second x minus the first x on the bottom. So you guys, what we're actually doing when we find the average rate of change over an interval, we're finding the slope. Okay, so check this. So here's my first. I like to go ahead and even turn it into an ordered pair because that way it goes ahead and it ties it into something that you already know. So if the x value is a 1 and I fill that in, 1 squared is a 1. If the x value is a 2, 2 squared is a 4. So my average rate of change is 4 minus 1 over 2 minus 1. 4 minus 1 is 3. 2 minus 1 is 1. So I end up with 3 over 1, which is 3. Now let's go ahead and look at the next one. 1, if I fill that in, it's a 1. 1.1. If I take 1.1 and I square it, I get 1.21. So if I have 1.21 second y minus the first y over the second x minus the first x. 1.21 minus 1 is 0.21. 1.1 minus 1 is 0.1. If I go ahead and take 0.21 divided by 0.1, I get 2.1. Now, let's go ahead and my x value is a 1. 1 squared is a 1. The next x value, I'm going to 1.01. If I take 1.01 and I square it, it's 1.0201. Now I can just find the slope between these 2 points. 1.0201 minus 1 over 1.01 minus 1. So if I go ahead and do my subtraction, on the top I have 0.0201. On the bottom, I have 0.01. If I go ahead and divide those two, I end up with 2.01. Okay, so one thing that I want to point out, if we're looking at the interval, now here, we're looking at the points where your x is 1 and 2. Here it's 1 and 1.1. Here it's 1 and 1.01. So it's like that idea of the secant line. Remember when we had 2 points and we kept making the horizontal distance closer and closer to 0? That's what we're doing here. This second point keeps approaching 1. And so they want to show you this relationship. It's so cool. So remember our notations. This means to find the derivative of the original. Well, if my original function is f of x equals x squared, the derivative of x squared is 2x. They want us to go ahead and take the derivative and fill in a 1. Notice we get a 2. So it's the same idea here. If you have your 2 points and your horizontal distance is approaching 0, meaning that the second point is getting closer to 1, you are getting closer to the actual slope at that point, the point that you're approaching, because it was 3, then it was 2.1, then it was 2.01. So as the points were getting closer together, the slope was getting closer to 2. And so that's what we should have noticed. Let's go ahead and do it again just because, you know, that was super, super fun. Here, let's make our ordered pairs. If I have a 2, negative 3 times 2 squared is negative 12. If I have 2.5, negative 3 times 2.5 squared is negative 18.75. If I am finding the average rate of change, I'm finding the slope. The second y minus the first y over the second x minus the first x. Now remember, because I'm minusing a negative, I'm actually adding there. So negative 18.75 plus 12, negative 6.75 over 2.5 minus 2 is 0.5. When I divide those two, my average rate of change is negative 13.5. Okay, now I'm moving the second point closer to the 2. It's going from 2.5 to 2.1. My first order pair is still 2 and negative 12. 2.1. Negative 3 times 2.1 squared is negative 13.23. Now we find the slope. Negative 13.23 minus negative 12 over 2.1 minus 2. This again is a plus. Negative 13.23 plus 12 is negative 1.23. 2.1 minus 2 is 0.1. So if I go ahead and divide those two, my average rate of change is negative 12.3. Let's do it again. Now this time the points are getting even closer. Okay, it's only 0.01. It's a 100th away. Super close. So 2 and negative 12. Now if I have 2.01, negative 3 times 2.01 squared, I get negative 12.1203. Find the slope. Negative 12.1203 minus negative 12 over 2.01 minus 2. Again, here we're adding. So if I go ahead and I take my negative 12.1203 and I add 12, I have negative 0.1203 over 2.01 minus the 2 is 0.01. Go ahead and divide them. I get negative 12.03. So let's make a little hypothesis here. Okay, when the points were half a unit apart, my average rate of change was negative 13.5. When they were a tenth apart, it was negative 12.3. When they were 100th apart, it was negative 12.03. What do you think the value is that they're approaching? Good, thanks for participating. Let's check it out and see if you got this. Okay, so we want to find what's called the instantaneous rate. Instantaneous rate is when you find the derivative and you plug that value in directly. So rather than an average rate between 2 points, instantaneous is right now at that exact moment. Okay, so if I want to do that, you take your original function, which is negative 3x squared. You find your derivative. 2 times negative 3 is negative 6. I had 2 x's, I reduce it, so now there's only 1. Now to find your instantaneous rate at 2. So at that 2, negative 6 times 2 is negative 12. Awesome. One more little idea for the day. When we are working on story problems, lots of times they will talk about things like distance or velocity or acceleration. And one thing that we want to be comfortable with is knowing, am I working with the original function? Do I have to find the derivative? Do I have to find maybe a second derivative? And here's the really cool thing. If you are looking for distance traveled, you use the original function. If you are looking at the velocity, it is time, at the time t seconds, you do a first derivative. If you are looking at acceleration, that's where you have to take the second derivative. Okay, so if they ask about distance, it's the original. If they ask about velocity, it's the first derivative. Acceleration is the second. Let's do this. A ball is thrown straight upwards. The function negative 16t squared plus 96t plus 5 represents the height of the ball in feet after t seconds. What is the velocity after 2 seconds? Velocity is the first derivative. So first I need to go ahead and find the first derivative. 2 times negative 16 is negative 32. T plus 96. Now to find the velocity at 2 seconds, you go ahead and fill in a 2. So negative 32 times 2 plus 96. Your velocity is 32 feet per second. Awesome. What is the acceleration after 2 seconds? Well, acceleration is a second derivative. So if I go ahead and I find the derivative of the first derivative, it's negative 32. Well, if I try to plug a 2 into a negative 32, notice there's not a variable. This is constant, so it's negative 32 feet per second squared. That's the acceleration at 2 seconds. It's negative because it's dropping. At what time is the velocity negative 32 feet per second? Velocity is first derivative. So you want to know what time is this equal to negative 32. So negative 32 equals negative 32t plus 96. Now we go ahead and solve for t. So minus 96 from each side. Negative 32 minus 96, I get negative 128 equals a negative 32t. Divide both sides by negative 32, and t is 4 seconds. When is the ball at a height of 133 feet? Okay, so what they're doing here is they're talking about the distance because they're talking about the height. That's the original function. So I'm going to go down here just so I have a little bit more room. Negative 16t squared plus 96t plus 5. When is that 133 feet? Go ahead and set it equal to 0 because now I can do the quadratic. Negative 16t squared plus 96t, 5 minus 133 is negative 128 equals 0. Okay, I could do the quadratic. One thing that's always helpful is to go ahead and see if you can simplify this. I believe I can divide all of these values by a negative 16. So that would be t squared. 96 divided by negative 16 is negative 6t. Negative 128 divided by negative 16 is 8. So by doing this, I went ahead and set it equal to 0. I could simplify it. This allows me to go ahead and factor. Two numbers that multiply to 8 and add to negative 6 are negative 2 and negative 4. So to find the possible times, or maybe there's more than one time, that the ball is going to hit 133 feet, you take each factor separately, set it equal to 0. So t equals 2 seconds and t equals 4 seconds. Now this makes sense because when you throw a ball, it goes up and then it has to come down. So let's say that it hits 133 feet here going up. Well, it's going to hit that same height again on the way down. So it is possible to have two different solutions. So for part D, you do have 2 times, 2 seconds and 4 seconds. Last one, when does the ball hit the ground? So that is the height again. So I go ahead and negative 16t squared plus 96t plus 5. When does it hit the ground? That means that the height is 0. Let's do the quadratic. A is negative 16. B is 96. C is 5. If I calculate B squared minus 4 times A times C. So it's 96 squared minus 4 times negative 16 times 5, I get 9,536. Now the square root of that is, it's a decimal, okay, so it's approximately 97.65. I'm going to go ahead and round it. So x equals negative b, plus or minus the square root of b squared minus 4ac is 97.65 all over 2 times a. A is a negative 16, so 2 times negative 16 is negative 32. Now to find your solutions, add the numbers on the top, divide by negative 32, subtract the numbers on the top, divide by negative 32. So negative 36 plus 97.65 equals, divided by negative 32, I have a negative 0.05. And I can't hit the ground at a negative value. Negative 96 minus 97.65 equals Then go ahead, divide it by negative 32. It's approximately, because I did round, 6.05 seconds. That's when the ball hits the ground. And that's the beginning of 1.8. There are 8 questions in the book that are awesome practice questions for these concepts. I'll talk to you soon.